All right, the second half, or this page 2 of section 5.4, measures of variation. The question is, how do you describe how spread out the data set is, right? We saw examples of 2 classes with the same average on the quiz, and one class had more widespread values or the scores than the second class, right? So how would you quantify how varied how spread out the data values are? And the answer, we have 2 measures of variation. The first one is called the range. Okay, what is the range? The range is what you think it is. It's the highest number minus the lowest number, maximum minus the minimum. All right, and so that sort of tells you, like, hey, what was the highest score on the test? What was the lowest score on the test? Oh yeah, so the range was between 20 to 50, and the range is between 25 and 40 or something, right? So that's the range. It is the numerical difference between those. So if the scores varied from 10 to 50, you say the range was 40, which is 50 minus 10. But what's really important from a statistical standpoint is this somewhat strange measure of variation called standard deviation, right? For reasons that are perhaps too complicated and beyond the scope of this class, this standard deviation turns out to be a very, very important measure of variation. In fact, it's so important that it is used extensively in what we will cover in the next section, which is about the normal distribution. It is the most common and the most important measure of variation, standard deviation. Now, it's going to take a little while to explain what that is, but it is measuring how widespread the data values are. Here is how you calculate this, right? How to calculate the standard deviation for a data set. The first thing is to find the mean, and then you find the deviation. Now, again, the word deviation seems to be, like, well, how far are you from some number? And that is correct. The word deviation tells you how far the individual number is from the mean. Okay, that is the deviation. But the word standard deviation is very different. This 2-word term, standard deviation, means a very specific number obtained from the entire data set. Okay, so there's one standard deviation for the entire data set, and there is a deviation for each value of the data set. Okay, so let me explain. Here's the formula here's the formula for the deviation first. Okay, so the deviation is the value minus the mean, and this is for each data value. Okay, you can calculate that, and I will do that in just a moment. And once you do this, then I'll do this in just a second, but then we add them. Well, actually, we then square each deviation, add them up, add the squares of the deviations, and I will tell you the rest of this, okay? Because it's a little more complicated than this. So let me I'll try to write this by hand as I go through this process. Now, because of the complexity of this process is often done by computer. If you go to Excel, you can find the standard deviation function, and you can circle or define all the numbers in the data set, and the software will calculate the standard deviation right away. But it is worth doing this once, okay? Because by hand, because then you will have a first-hand, not a pun, but a first-hand experience in how to calculate the standard deviation. All right, so here we go. This is how you find the standard deviation for a given set. I'm going to use this set first. This is class A, remember? Class A had the mean of 30. And the scores were 10, 20, 30, 40, and 50. By the way, before I go further, I should mention the standard deviation. We use this word, Greek letter sigma. And sigma is like a circle with a little tail and on the top. Okay, so this is the lower Greek letter sigma. Capital Greek letter sigma looks like this. It's a very different one. But the lower Greek letter sigma is like this, and this is the notation used to describe the standard deviation or to refer to the standard deviation. Right? Mean, on the other hand, because the letter M is at the first of the word mean, this is M. Okay, so this is, in fact, this is called the mu. Right? This is the Greek equivalent of our M, and this is the lowercase mu, and that represents the mean. The standard deviation is described as sigma. Okay, let's go on to find the deviation. Now, remember the deviation. By the way, this process is not hard. It may be time consuming, but it's not too difficult. And you don't have to do this over and over again for this class. But like I said, it is important for you to experience this once, right? For each data value, the deviation is simply the difference between the value and the mean, value minus the mean. So 10 minus, remember the mean is 30, right? 10 minus 30. That's, of course, negative 20. You know what? I'm going to just write down negative 20 here. I think maybe that's easier. All right, so negative 20 is the answer for the first deviation. And the next one is 20 minus 30, so that's negative 10. 30 minus 30 is 0. 40 minus 30 is 10. And 50 minus 30 is 20. All right, so those are the deviations. For each value in the data set, we calculate the deviation. If you add up the deviations, by the way, the total is going to be 0. And that's by default. And it's always going to be 0 if you did the calculations right. So the sum of the deviations don't tell you much. It's always going to be 0. So what we do is to square the deviation. For one thing, it's going to make everything positive. It's 400. 10 squared, negative 10 times negative 10 is positive 100. 0 squared is 0. 10 squared is 10. I'm sorry, 100. 20 squared is 400. Now all the numbers are positive. And then you add them up. Okay, you add them up. And then what you get is 400 plus 100 plus 400 plus 100. That's 1,000. Okay. And so now what we do is as follows. Let me go ahead and tell you how to do this. The standard deviation, sigma, is equal to, and here's a big expression, the total, let me say sum, the sum of the deviations squared. Okay, so you square the deviation, add them up. The sum in this case was 1,000. And you then divide it by n minus 1, where n is the number of data values. How many numbers do you have in this data set? N in this case is 5 because I have 5 numbers in here, right? So you would think you may divide by 5 to find the average of the deviation square, but it doesn't work that way. For a sample standard deviation, which is what we are doing, you divide this sum of the deviation squared by n minus 1. In this case, it's 4. And then you take the square root of that. Okay, so let me go ahead and do this. For class A, the standard deviation will be the square root of 1,000 divided by 5 minus 1. Okay, so this is the square root of 1,000 divided by 4. That's the square root of 250. And this, according to your calculator, is going to be about 15.8. If you're in algebra class, you would write this as 5 times the square root of 10. And sure, that's another way of doing that, but you don't have to. You can find the decimal representation of this. So this 15.8 is the standard deviation of the scores in class A. All right, let's do another example. This class B, remember class B had the same mean of 30. Okay, but the values or the scores were not as spread out as in Class A. Class A ranged from 10 to 50, so the range was 40. Here, the range is 40 minus 20, which is 20. All right, the deviation would be this number minus 30, that's minus 10. 25 minus 30 is minus 5. 30 minus 30 is 0. 35 minus 30 is 5. 40 minus 5 is, I'm sorry, 40 minus 30 is 10. And then in the next column, we square what we just obtained. Negative 10 times negative 10 is 100. Negative 5, quantity squared is 25. 0 squared is 0. 5 squared is 25. And 10 squared is 100. You add them up. This case, you have 250 as your sum. So you go over here, and for Class B, the standard deviation sigma is the square root of 250 divided by 4. Okay, and you can just go ahead and do this on your calculator. This will come up to be 7.5. In fact, by using a bit of algebra, you can show that this is exactly half of this. Okay, and that's because the inside of the square root is, 1,000 is exactly 4 times as much as 250. But this indicates, all right, so this is a numerical value that represents how spread out the scores are in Class B. Class A had much bigger standard deviation, indicating that the scores in Class A were more widespread than Class B. Okay, all right. So you can say the standard deviation was twice as much in A compared to B. Why is this so important? Again, it is kind of, and by the way, why do you also divide by 4, not 5, right? Those are the questions such that to answer those questions, I would have to explain something beyond, much beyond the scope of this class. And in fact, it's probably beyond the scope of a standard introductory statistics class. I learned why this is n-1. There has to be n-1 for sample standard deviation in, I think, one of the most advanced undergraduate mathematics course in mathematical statistics. So it's pretty hard to figure out why n-1 is the best unbiased standard deviation for a sample. But it is, okay? That's what mathematics will tell us. All right, so this is how you find your standard deviation. You will have maybe 1 or 2 examples to do on your homework, but not many, because this whole process is really not something that you want to spend much time on. But I do want you to do this a couple of times on your own, so you know what the standard deviation is and how one can obtain that. All right, so let's finish this section by looking at this last set of problems. Now, I should say this last set of problems is very likely to be on the exam. I will have questions like this, probably on your homework and on the exam, because these are the kind of questions that I believe would test your understanding, not just knowledge, okay? So make sure you know how to answer these questions, numbers 1, 2, and 3 here. Let's look at number 1. Oh, by the way, for all of these 3, the instruction is to come up with an example of 2 data sets, A and B, okay? And each of these sets should have 5 numbers, such that, number 1, A and B have the same mean, but different median. Okay, so can you come up with a set of 5 numbers A and another set of 5 numbers B so that they have the same mean, but different median? If you look at Class A and Class B, they do have the same mean, right? 30 and 30, but they also have the same median, which was 30. So that doesn't give you an example you want. Okay. So how do you think about this? How do you begin to think about this? Here's an idea, okay? To have the same mean, the sum of all, see, I want to have 5 numbers in each set, right? So the sum of all values in the set must be the same. Okay, in other words, the sum of all the numbers in A must be equal to the sum of all the 5 numbers in B. Okay, That's a requirement, but you can change anything else, and especially the median. So here's an example. You can have a lot of different examples here. Let's say 10, 20, 30, 40, 50. That's your A, okay? This part is easy. You just come up with whatever, okay? Because B is the hard part. You know, what is another set which has the same mean but different median, right? So I have to have 5 numbers that add up to 150. That's pretty much the only requirement. And I don't want the middle number to be 30. So how about something like 0, 0, 0, 0, 150? Okay, because certainly they add up to 150. And now the median is 0. You see that? The middle number is 0. Here, the middle number is 30. Okay. Now you can have like 10, 10, 10, 10, 110. Or, you know, I don't know, 1, 2, 3, 4, and 140. As long as the sum of your 5 numbers in B is 150 and the middle number is not 30, you are okay. All right, let's go to the second question. A and B have the same median this time, but different means. All right, to have, so I should say A and B must have the same middle number when ordered from, you know, the lowest to the highest or so on. But the different means that different means mean that the sum must be different in A and B to have different means. Okay, so let's do an example here. A could be, as before, 10, 20, 30, 40, 50. Okay, I like to use the same thing. You don't have to. But then now notice here, B must have what? B must have the middle number as 30. So how about this 0, 0, 30? Okay, oops, 30, 30, 30. Okay, it has to be in ascending or descending order. Clearly, A has the average of 30. B has the average of what is that? It's 90 divided, 30 plus 30 plus 30, which is 90 divided by 5. That's the average of 18. The mean is 18 for B, but the median is the same, right? So you have to think, and you have to sort of be creative. It's going to make you use the different parts of your brain, and that's critical thinking. That's expanding your thinking abilities. That's why these are great questions. And that's why you are going to see them on your exams and homework. Okay, A and B have the same mean. So A and B must have the same sum, right? Because the same mean. And A has larger standard deviation. A must be more spread out. Okay, we already have an example in the our classes, class A and class B, and their 50-point quiz score. But let's come up with another example. Let's say A is 10, 20, 30, 40, 50. And to be consistent, I should have an equal sign here. And B should be, now I have to have the same sum. So the whatever the numbers are, the 5 numbers in B have to add up to 150. But they also must be widespread, the bigger standard deviation. So how about if I go to like 0 and 10 and 30? And these don't have to be a 50-point quiz. So how about how about 50? Do I have enough? So yeah, I think that would be okay. Maybe I can do 40. No, 50 is okay. All right. Now remember, the sum has to be 150. So I think the next one I have to do is 60. Right. Here the average is 30. Here the sum. Remember, the sum is 150. So the average, the numerical average or the mean for B is also 30. So they do have the same mean, but the standard deviation of B is much bigger or somewhat bigger because the numbers are more widespread compared to A. All right, so good exercises. All right, I like these. Did I mention you may see them on the exams? Or you will definitely see them on exams. Yes, you will. So make sure you study these. All right, it's time for your quiz. Do these ahead of time before you go on to the online quiz for section 5.4. And that is the end of section 5.4. Do not forget to do your homework. Next time, I'll see you when you are ready to go on to the last section of chapter 5, which is 5.5. Take care and have a wonderful day.